This is Mrs. Haslauer's second video for transformations. Today we're going to be looking at something called a reflection. It's different from the translation that we did yesterday. Again, the translation is just a slide. We're sliding left, right, up, down. The reflection is actually flipping the shape over an axis or over a straight line. The three things you really need to focus on today by the end of the video is how do you reflect over the y-axis, how do you reflect over the x-axis, those are two rules that you are expected to know how to do, and three, what happens to the shape when you complete a line reflection. Just like I had yesterday, I have an example of the reflection on this computer program. So if I were to paint this object here, all right, with actual paint, if this was on a piece of paper, folded it along the y-axis, I would get this shape over here. They're completely congruent, but what happened is that this arrowhead flipped over the y-axis. Please notice, guys, that they're the equal distance away from the y-axis. They're completely the same. The shapes haven't changed. It's perfectly symmetric. Symmetric means same. Now, the same thing is true if I were to reflect the shape over the x-axis. When I reflect it over the x-axis, though, the shape goes from the fourth quadrant up to the first. Why? Because again, a reflection is like folding the paper over. If this was paint instead of on the computer, you would end up with this flipped shape up here. This is what we're going to do with a reflection. Now, there's specific rules to make sure that you get the right answer. And we're going to look at that in our notes today. So again, the line reflection is when an image is reflected over a line called the line of symmetry. It's very important to understand that and be familiar with that. Because again, symmetry just means same. The size of the shape of the object are unchanged, but the image is flipped, making a mirror image. I gave you a couple examples here in the pictures. Here's the E. When it's reflected over the line, it flips over it, and you end up with the image right here. Same thing is true with just basic shapes. Again, please notice that they're equidistant from the line of symmetry. And then you can also see reflections in nature. The line of symmetry would be right here where the ground meets the water, and then you end up with a perfectly symmetric image. Now, there's two types of reflections. You'll be expected to be able to do one with and without graph paper. If there isn't graph paper, you do the absolute best you can to reflect it over whatever line they're presenting. These are three examples of vertical lines. You try your best, guys. So imagine that this is paint, all right, instead of being on your paper. And then you fold it along this line. The dot would reflect approximately here. All right, it's not perfect. If I had a ruler, I could measure it. From this point to the line needs to be the exact same from this point to the line. But I don't have a ruler, so I have to do the best I can. Here's half of a heart. When it's reflected over the line, you're going to, over the line of symmetry, you try to draw the best you can, and you end up with a heart. And then the E, I'm going to use a straight line for that one. Try to make it the same distance away from your line of symmetry. And you need to keep the shape the same. So the top and bottom lines need to be the longest. They need to be equal to each other. And then you end up with a shorter one in the center. That's how you reflect without graph paper. Now we're going to reflect with graph paper. So here we go. Now reflect the image using graph paper. This will allow you to achieve a more exact reflection. Again, if you had a ruler, I could have done a better job at the top, but I don't. This one's more straightforward because you have the X and the Y axis. Very important to label. This is a reflection over the Y axis, so I'm going to put a big Y right here. Very important to draw your attention to it. Here's quadrant 1, quadrant 2, quadrant 3, and quadrant 4. It's important to know and be able to identify all four quadrants. What we're going to do is reflect the trapezoid PQRS over the y-axis with the following vertices. So we start at the origin. We're going to graph 4, -2. Some of us were forgetting to label yesterday. We don't want that to happen. Make sure you label Q, 8, 4. Make sure you're paying close attention to the positives and the negatives. Yes. Now you are going to use a ruler. I don't have a ruler, but I have a straight edge, so I'm going to use this. I can make straight lines. Now, what we would have done yesterday is come up with some sort of rule that would have told us to move left, right, up, or down. We're not doing this today. Today we're actually reflecting. And in this case, we're reflecting over the y-axis. So you don't even care that the x-axis is there at this moment. This is your line right here of reflection. It's very simple, but it's very easy to make a mistake and go to the wrong line. So what you're going to do is put your pen on your vertices, just like we did yesterday. It's always important to put your pen on the corners, and you're going to count to your line of reflection. So how far away is this point, is S, from the y-axis? 1, 2. So what you're going to count is 1, 2, and you're going to label it S prime. Because what we're doing is, if this was in black paint, if we fold it over the y-axis, we want to know where the shape would fall. Put your pen on R. 1, 2, 3, 4, 5, 6, 7, 8. It's 8 units away from the y-axis, so you're going to count 8 units in the other direction. 1, 2, 3, 4, 5, 6, 7, 8. R prime. P. 1, 2, 3, 4. 1, 2, 3, 4. P prime. And finally Q. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Notice that the shape should still be the same. We have not changed the size of any of the angles, of any of the side lengths, nothing. Before we proceed, let's do a quick check. How many units is it from Q prime to P prime? 1, 2, 3, 4. Over here, 1, 2, 3, 4. The top one, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we're good. We've got the exact same shape. Very important to check before you proceed. And now they want you to compare the coordinates. So I already wrote out the coordinates for you of the original. I want you to come up with the coordinates of the image. So this was P first. So now we're after P prime. P prime, you start at 0. Walk 1, 2, 3, 4. So the coordinate is -4. Fall to -2. Q prime, right here. You're going to walk to -8. Fall to -2. R prime is -8, 4. And S prime, -2, +4. Now, counting is fine, but there's also a rule you have to know. If you're comparing your coordinates, notice that P is 4, -2, and P prime is -4, -2. When you look down and compare your results, hopefully you see something that stayed the same and something that changed. What happens is that the X value changes sign. And the Y value stays the same. This is very, very important for you to understand. When you reflect over the y-axis, notice that all the y values are still the same. -2, -2, -2, -2, 4, 4, and 4, 4. What changed is the sign on the X. You went from 4 to -4, 8 to -8, 8 to -8, and 2 to -2. The numbers are still the same, but the sign on the X changes. It's kind of like the opposite. When you reflect over the y-axis, you change the sign on the X. All right? You do not worry about the Y at all. Now, counting will always work, but it's also important that you know the rule. And how you're going to see the rule is lowercase r, R is for reflection. You take whatever your XY is, that's your original coordinate. What you're going to do is negate the X and keep the Y the same. So here's your rule in standard form. Again, why did I use an X and a Y? Because that's what every coordinate is made up of, an X and a Y. Now let's go through the same thing, only we're going to reflect over the X axis. We're going to reflect this parallelogram. So quickly graph your points. Make sure you label. Connect your parallelogram with a straight edge. Now, instead of reflecting over the y-axis, we're reflecting over the x. So, very important. If I were you, I would label the x-axis. The x-axis is this horizontal line. You know that. But it's going to be very easy to accidentally count to the wrong line. Please, please take that extra step to focus your attention on the line that you need. We need the x-axis. Now, all we're going to do is count, just like we did before. O is 1 away from the x-axis, so you count 1 away and label it O prime. M, 1, 2, 3, 1, 2, 3. M prime. N, 1 away, you count 1 away. Y, 1, 2, 3, 1, 2, 3. Now, even though you're saying to yourself, oh goodness, this is really easy, good. Yes, I want you to feel that way. I hope you feel that way. But it's so simple to accidentally count too many or count too few. So you need to be careful. This is not something that you're going to go really fast on. And now by giving it a quick look, notice that the two images are perfectly symmetric, guys. They're the exact same shape. All we did is reflect it over. We flipped it over the x-axis. Now if we write our coordinates, so just like we did before, we're going to record our coordinates of our image. M prime, let's see, M prime's right here. Start at 0, 0, walk to 2, fall to -3. O prime, walk to 1, fall to -1. N prime, walk to -4, fall to -1. And Y prime, walk to -3, but then fall to -3. When you compare the results, 2, 3 is now 2, -3. 1, 1 is now 1, -1. -4, 1 is now -4, -1. And -3, 3 is now -3, -3. The numbers didn't change. They did not change. The x's stayed completely the same. The only thing you did, which changed the entire shape, it moved it all the way down, it flipped it right over that x-axis, is by negating the y value. All of these y values have changed the sign. So that's your rule. That's what's going to happen every single time you reflect over the x-axis. The y changes sign. So again, that's where I want you to write this right here so that you don't forget, because this is very, very important. The x value stays the same. Again, just like on the y-axis, you negated the x. When you're reflecting over the x-axis, you negate the y. It's kind of like the opposite. So the x value stays the same, but the sign on the y changes. All right? Now, if that doesn't make sense to you, write it in a different way. It technically negates. Negates is the math term. It's going from positive to negative, or if it was negative, it would go to positive. That's the important thing for you to understand. So now again, in standard form, lowercase r for reflection, whatever your x, y is, no matter what the coordinate is, if it tells you to reflect it over the x-axis, you're going to keep the x the same and then change the sign on the y. So you have two very important rules to know by the end of this video. You have to understand how to reflect over the y-axis, and you have to know how to reflect over the x-axis. When you reflect over the y, you negate the x, and when you reflect over the x, you change the y. It's kind of like an opposite. Now, we don't have time to do question number 3, so this right here is where we're going to start tomorrow's lesson. When you get in to class, you're going to take out your note sheet and you're going to begin with your partner on number 3. All right, this one has you doing more than one operation on the same piece of graph paper, so make sure you're very, very neat.
Getting